Okay, here we go. Last set of problems. So now we get into the ones with I call sticker shock value. Because you look at this and go, ugh, which is the same face you make when you find the perfect thing that you want to buy, and then you look at the price tag and go, ugh. So, yay, I'm so old, I explain the memes when I use them. Yeah. All right. So we got cotangent and cosecant in here. So up here we got remembers. Cotangent is cosine over sine. Cosecant is 1 over sine. So we are going to have two different signs pop up in here, which is our as x goes to 0, go to 0 and create problems. Because we also have, and it's really easy to miss this, there's an x squared hiding up front. And we're going to make use of that to get our sine theta over theta, or what happens if we stand that on its head? Theta over sine theta, it still goes to 1. All right, so cotangent here. That is going to be the cosine of 3x over the sine of 3x times cosecant of 8x will be 1 over the sine of 8x. And then we still have that x squared just hanging out up front. So our cosine here, totally fine. We plug in 0, cosine of 0 is 1. So we're good with that guy. Whenever we're ready to evaluate the limit, he'll be fine. But the sine 3x and sine 8x, those need some x's, which we already have, so we don't have to do like creative multiplication to get them in. We just have to rearrange. So our cosine 3x, we'll just leave him up front. And then I've got one of the x's is going to go with sine of 3x on the bottom. And then the other x is going to go with sine of 8x on the bottom. Now, just like we did before, I need what I'm taking the sine of to match the other part of its fraction. So this sine of 3x, this needs to be a 3. If I want to put that 3 up there, I have to balance it. So I'm going to give the cosine a fraction bar, and I'm going to put a 3 down here. Then we also have over here the sine 8x. I need that to be an 8. So over here, I need to balance that. 8 on top, 8 on the bottom. 3 on top, 3 on the bottom. All right, now the limit of each of these, this limit goes to 1. This limit goes to 1. So we really only have to consider the limit as x approaches 0 of the cosine of 3x over 3 times 8. So this will be the cosine of 0. Cosine of 0 is 1. 3 times 8 is 24. So that is a whole lot of work to get 1/24. So it looked bad at first, but we know we're looking for that sine theta over theta, or in this case, it ended up being theta over sine theta, ugly over sine ugly. So when we know that form is good for us, like, you just gotta move stuff around until you see it. Like, force it to be there. One more, and this one is a like, why? Totally fair. Why? All right, so on top, I've got a conjugate. But now look at our remembers. Sine theta over theta, yeah, I see that sine squared on the bottom. But then 1 minus cosine theta over theta. Oh. Now that subtraction I have on top isn't quite so bad, because I can do the same ugly, and it works. Now this one I can't flip. I can't do theta over 1 minus cosine theta. But, because then it would be 1 over 0 if we got a problem. But like this, I can still use it. So the first thing we want to observe is this t minus t cosine 14t. Those t's on the outside are a common term that can be factored out. So we have t times 1 minus cosine 14t. That should be looking a little more, oh yeah, I'm seeing it now. Over sine squared of 16t. So that square makes things a little interesting. But I do know one of my limit laws was I can put the limit inside an exponent. But that does mean, since this is sine squared and I'm going to put the limit inside, I need the other half to end up being inside the squared. So for our t that we have up top, I actually need a t squared. But this is okay because my 1 minus cosine also needs a t on the bottom. So it's totally fine if I'm like, well, I need another t. But it works out because I need one on the bottom too. And that's like how you know you're on the right track, when it's like, oh, yes, because we don't give you the ridiculous problems where you're like, I don't know if this will do anything. We're like, no, 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 we picked it on purpose. It goes somewhere. You just got to find it. All right, so we multiplied by a crazy form of 1. This is still equivalent. I'm just going to rearrange the way it's written. So I have a t squared and a sine squared of 16t times 1 minus cosine of 14t over t. So now this is the point where my brain is like, all right, I got my guy over here on the right that's going to go to 0. Who cares what the other one goes to as long as it's not indeterminate? That is actually one way to kind of go from here. Because remember, the limit 1 minus cosine ugly over ugly, 1 minus cosine 14t over, well, it's not the same ugly, but we can fix that. 14. Cool. Now it's going to go to 0. 14 times 0 is 0. I know over here, I just need to play with a number, put the other number over here, and it's still times 0, and it's going to be 0. But I'm going to go through it because if we didn't have our going to 0 limit, this other one would actually be a little more awkward. And so you do want to know, what number would I have to put? How would I balance that out? So what we want to see structurally in this guy is that we want to be able to write sine of 16t, whole thing squared, and then we need our matching 16t inside the parentheses that are being squared. So I don't just need a 16 on top, I actually need a 16 squared on top. So that means over here, we're going to end up having to divide by a 16 squared. All right, so now all of my limits are actually of the correct form. They will work, and we will get our 0. So still the same answer, but on the off chance you get this where it's not going to go to 0, you need to know that that 16 had to be squared, otherwise your answer is off, and then, you scream and hopefully don't break your computer. But I know how frustrating web work can be. And that concludes the ridiculous long lesson of the limit laws, which generally is plug it in, a meme older than all of you. If that doesn't work, try some weird algebra. If that doesn't work, but you got like a sign in there, maybe a squeeze theorem, but probably not on a test because that would be mean. Seriously, not on the test. Because it's in your writing assignment. And then trig limits, we look for these particular forms because we can use those to reduce parts of the limit that are being annoying. All right. that's all I got. So I'll go ahead and end it here and I will post these videos. Honest, end it.